Hey everyone, welcome back to our channel where we make science fun and easy. In today's lesson, we're going to learn about Newton's third law of motion. So if you're ready to learn, then let's get started. Newton's third law of motion is one of the fundamental principles of classical mechanics, formulated by Sir Isaac Newton in the 17th century. It describes the interactions between two objects and establishes an important relationship between the forces that they exert on each other. Statement of Newton's third law of motion. Newton's third law states, for every action, there is an equal and opposite reaction. This means that if one object exerts a force on a second object, the second object exerts a force equal in magnitude but opposite in direction. On the first object, let's see the formula for Newton's third law of motion. If F subscript 1, 2 is the force exerted on object 2 by object 1, and F subscript 2, 1 is the force exerted on object 1 by object 2, then according to Newton's third law of motion, the following equation holds true. F subscript 1, 2 equals negative F subscript 2, 1. This equation shows that the force exerted by object 1 on object 2 is equal in magnitude, but opposite in direction to the force exerted by object 2 on object 1. The force pairs often referred to as action and reaction forces act on two different objects. Importantly, they do not cancel each other out, because they act on different bodies. Let's understand the key concepts of Newton's third law of motion. 1. Action and reaction forces. Force pairs are often referred to as action and reaction forces. These forces act on two different objects and are always equal in magnitude but opposite in direction. For example, if you push a wall, the wall exerts an equal and opposite force on your hand. It's crucial to remember that these forces don't cancel each other out. They act on different bodies, so they both exist simultaneously. To represent this, we use subscripts to denote the objects involved. F subscript wall on hand represents the force exerted by the wall on your hand, while F subscript hand on wall represents the force exerted by your hand on the wall. These forces are equal in magnitude and opposite in direction. 2. Simultaneity. Action and reaction forces occur simultaneously. When one force is applied, the corresponding reaction force occurs at the same time. This means that there is no delay or sequence in the application of these forces. For example, when you push against a wall, the force you exert on the wall and the wall's response force on your hand happen instantaneously. 3. Interaction between objects. Newton's third law emphasizes that forces arise as a result of interactions between objects. Each force needs some form of interaction to exist. There cannot be an isolated single force. For instance, if you try to push your hand against nothing, you won't feel any resistance because there is no object to exert a reaction force. The concept of an isolated single force is not physically meaningful. Let's now discuss some of the implications of Newton's third law of motion. 1. Equal forces, different effects. Although action and reaction forces are equal in magnitude, their effects can differ because they act on different objects. Consider a person standing on the ground. The person exerts a downward force, equal to their weight onto the ground. This force would cause the person to accelerate downward, if there weren't another force acting on them. However, the ground exerts an equal and opposite upward force on the person. This upward force is what supports the person and prevents them from accelerating downward. In this scenario, both the person and the ground are accelerating. But because the mass of the Earth is much larger than the mass of the person, the acceleration of the Earth is negligible, so it appears that only the person is accelerating. Therefore, although the forces are equal, the effects on the two objects are not the same due to their different masses. 2. No movement required. The fact that action and reaction forces are equal does not mean that objects must move. They can be in equilibrium when these forces are balanced. For example, a book resting on a table experiences two forces, the force of gravity pulling it down and the normal force from the table pushing it up. Since these forces are equal in magnitude and opposite in direction, the book remains at rest. It is not moving. So friends, these were the key concepts and implications of Newton's third law of motion. Now let's look at some real-world examples. 1. Walking. When you walk, your foot pushes backward against the ground, applying a force. This is the action force. The ground simultaneously pushes your foot forward with an equal force, which is the reaction force. This reaction force propels you forward. 2. Swimming. A swimmer pushes the water backwards with their hands and feet. This is the action force. The water simultaneously pushes the swimmer forward. This is the reaction force. This reaction force helps the swimmer move ahead. 3. In a rocket, the engines expel gases downwards, applying a force. This is the action force. The reaction force pushes the rocket upwards. This is the reaction force. This reaction force is what propels the rocket into space. 4. Sitting in a chair. When you sit on a chair, your body exerts a downward force on the chair due to your weight. This is the action force. This reaction force prevents you from falling through the chair. 5. Recoil of a gun. When a bullet is fired from a gun, The force exerted on the bullet by the gun is equal and opposite to the force exerted by the bullet on the gun. As the bullet moves forward, the gun recoils backward. This is why you need to hold on tightly to the gun when firing it. So friends, Newton's third law of motion is an essential principle for understanding how forces interact between objects. It highlights the reciprocal nature of forces and is a critical principle that applies to a wide range of phenomena in everyday life, as well as advanced scientific and engineering applications. By grasping this concept, we can analyze and predict the effects of various interactions in mechanical systems, engineering, and physics as a whole. We hope you found this lesson on Newton's third law of motion to be informative and easy to understand. If you enjoyed the video, please don't forget to give it a thumbs up and share it with your friends. We would love to hear from you in the comments below. What topics in physics would you like to see us cover next? Your feedback is very important to us and helps us create more great content for you. So thanks for watching, and see you in the next video.